Most real-time AI demos you see online are secretly cheating. There's a server somewhere, an API call happening in the background, a GPU cluster doing the heavy lifting. You just don't see it. So when a developer named Fikri Karim posted a project called Parlor Real-Time Multimodal AI, video in, audio in, voice out, running entirely on a MacBook with an M3 Pro chip, no cloud, no API keys, no internet connection required, I had to dig in. Because if that's real, it changes something. Parlor is an open-source project built around Gemma 2B, Google's smaller open-weight language model, combined with local speech recognition and a text-to-speech pipeline, all stitched together to run inference in real-time on Apple's silicon. You speak to it, it watches through your webcam, it talks back. Locally. On your laptop. Let's be precise about what that actually looks like. You run the stack, your webcam activates, your microphone is live. You hold up an object, say, a book, and ask what it is. The model processes the video frame, combines it with your audio input, generates a response, and you hear a synthesized voice answer you. The whole loop. On one machine. The latency isn't zero, we'll get to that, but it works. It responds. It's not a demo with pre-recorded outputs. It's live inference. The multimodal part is what makes this technically interesting. Most local LLM setups you see are text in, text out. Getting audio and video to feed into the same inference pipeline, in real time, on consumer hardware, without everything grinding to a halt, that's the hard part. Parlor uses a combination of Whisper for speech-to-text, Gemma 2B for language reasoning, and a TTS backend for voice output. The video frames are sampled and fed as visual context. It's not magic, it's careful orchestration, but the result is something that genuinely feels like a local AI assistant that can see and hear. Now here's where honesty matters. What Parlor does not do is match the performance of cloud-based multimodal models. Gemma 2B is a small model. It will misidentify objects. It will give shallow answers to complex questions. It will occasionally lose the thread of a conversation. The response quality is not GPT-4v. It's not even close. And the latency, depending on your M-chip generation and thermal state, can be anywhere from 1 second to several seconds per response cycle. For a real-time conversation, that's noticeable. It doesn't feel instant. What surprised me was the memory footprint. Running the full-stack video capture, audio transcription, language model, TTS, you're looking at significant RAM usage. On a base M3 Pro with 18 GB of unified memory, you're consuming a large chunk just to keep the pipeline alive. That leaves less headroom for anything else running on the machine. And if you push it, long conversations, high-resolution video input, thermal throttling becomes a real factor. The M3 Pro is impressive, but physics still applies. There's also no persistent memory between sessions. Each conversation starts fresh. The model doesn't learn from previous interactions. And the voice output, while functional, is clearly synthetic. It doesn't have the naturalness of something like 11 Labs, which uses deep learning voice cloning to produce output that's genuinely hard to distinguish from a human. For a project like Parlor, integrating a higher quality local TTS engine would be the single biggest UX improvement. So where does this realistically go? The honest answer is edge deployment. Think about environments where cloud connectivity is either impossible or unacceptable: remote fieldwork, medical devices in secure facilities, robotics systems that can't afford latency from a round trip to a server. Parlor, or something built on its architecture, becomes a legitimate option when the constraint is offline operation. As Apple Silicon continues to improve M4, M5, whatever comes next, the performance ceiling rises. A model that struggles at 2B parameters today runs comfortably at 7B in 2 years on the same form factor. There's also a privacy angle that's underappreciated. Every frame you send to a Cloud Vision API, every word transcribed on a remote server, the data goes somewhere. A fully local pipeline means the conversation never leaves your machine. For enterprise use cases, healthcare, legal, defense, that's not a nice to have, that's a requirement. Why does Parlor exist? Because the dominant assumption in AI deployment is still that you need the cloud. Big models, big servers, API keys, rate limits, monthly bills. Thickery built this to challenge that assumption at the hardware level. Not with a theoretical argument, but with a running demo. The message is, the hardware is already here. The models are already small enough. Someone just had to connect the pipes. That's what Parlor is, a proof of concept that the pipes can be connected, on hardware you already own, without asking anyone's permission or paying anyone's subscription fee. It's rough. It has real limitations. But it runs. And in 2025, that matters more than you might think. If you want to go deeper on local AI deployment, what it takes to actually ship something like this to users, not just run it on your own laptop, that's exactly what we're covering next episode. Subscribe so you don't miss it.